Hello and welcome back to my channel. If this is your first time here, my name is Shireen and today I'm going to be talking about retinoids. So this will be a skincare video, and in my skincare videos I'll pick a skincare ingredient and then I'll do a deep dive, which means that I'll talk about its structure, the mechanism whereby it works, the effects that it has on your skin, and I'll kind of do a literary review of some studies that aim to establish its efficacy as a skincare ingredient. Before I dive into the actual video, I want to quickly talk about my makeup look in case anyone has any questions. This is the same look as in my glowy skin summery makeup tutorial, and the only difference is that instead of the Anastasia Beverly Hills Spicy lipstick, I used this Too Faced Melted Matte lipstick in the shade It's Happening. The Too Faced Melted Matte liquid lipstick line is my favorite liquid lipstick line, and I think the formula is really comfortable, and I think that some of the colors are just like the perfect version of that color. So I have this hot pink, I have a red, and then I also have a peachy nude. I highly recommend this. That said, I recommended this to a couple people and the formula just was different on their lips than it was on mine. So of course my recommendations don't necessarily translate to you loving the product. Okay. Now let's talk about retinoids. I have a blog post that corresponds to this video, so if you prefer to kind of process this kind of content by reading as opposed to listening and looking at me talk about it, then please check out my blog post. You will find it down below. The content is exactly the same as what I'm going to be discussing, so I will be referencing it, and for some of the more technical parts, I'll just be reading straight off of my laptop. Retinoids are byproducts of vitamin A, and they're found naturally in your body. They have a lot of different functions in your body. In skincare, they essentially work by strengthening the skin's extracellular matrix. They're lipophilic molecules because they have a nonpolar chain composed of carbon and hydrogen atoms. The fact that they're lipophilic molecules means that they can dissolve in fats and also that they can diffuse through the cell membrane. The cell membrane has a polar exterior and a nonpolar interior, so it's composed of the lipid bilayer, and something that's nonpolar can go through it, whereas something that's polar can interact with the exterior but can't really go in, so it can't actually enter the cell. So once the retinoids diffuse into the cell, they can bind to certain receptors and modulate the expression of genes. That means that they can get certain genes to transcribe the proteins that they correspond to, and then those proteins can run off and have other functions in your body. So broadly speaking, these proteins can do things that reduce fine lines and wrinkles, improve skin tone, and fade dark spots. I'll be talking about all this more in depth in a few seconds. So the two main forms of retinoids used in skincare are retinol and tretinoin. Retinol is how you'll probably find retinoids in over-the-counter skincare products. Retinoin, on the other hand, is a stronger ingredient, I'll talk about why in a second, and it'll usually be prescribed by a dermatologist for acne or severe signs of aging. It's important to note that the only kind of retinoid that your skin actually uses is retinoic acid. So any retinoids that you apply will be converted to retinoic acid via a variety of pathways. So although your body naturally produces retinol, when applied topically, enzymes in your skin convert the retinol to retinaldehyde, which means that the alcohol group at the end of that carbon chain we talked about gets converted to an aldehyde group. And then that aldehyde group gets converted into retinoic acid, which means that the aldehyde, now at the end of the carbon chain, becomes a carboxylic acid group. So this two-step conversion from alcohol to aldehyde to carboxylic acid has a high activation energy, which means that it's a slow reaction. It occurs over the course of several weeks, which means that all the molecules don't undergo it at the same time, and some of the molecules don't undergo it at all. The implication of this for you as a skincare user is that you have to be patient while waiting for your retinol products to take effect, and you should be using them consistently for best results. Tretinoin, on the other hand, is another term for retinoic acid. So it doesn't need to undergo that two-step conversion. It already has the carboxylic acid group. So the fact that it doesn't need to undergo this conversion or reaction means that it's 2 orders of magnitude more potent than retinol. This amplified skin renewal process through the amplified effects means that you'll see results as well as negative side effects such as irritation, flakiness, dryness more quickly and more impactfully. I've only personally ever used retinol. I've never used tretinoin, and I've never experienced any negative side effects, but I have heard from users of prescription retinoids that it is very, very common and expected to have some dryness, have some flakiness, have some peeling. Now that we've gone through the basics, I'll delve into a more detailed explanation of how retinoids function. So, once your retinoid enters the cell, at this stage it'll be retinoic acid, and it'll bind to a retinoic acid binding protein, which then takes the retinoic acid to the nucleus. Remember that if it has to modulate gene expression, it has to be in the nucleus because that's where the genes are. Okay. In the nucleus, it binds to another receptor. This complex of the retinoic acid and the receptor then binds to a response element on the DNA, which modifies the transcription of certain genes, which leads to the creation of certain proteins. This can also inhibit the creation of certain proteins. So, this process serves 4 functions. Function 1, it prevents the activation of matrixins. Matrixins are enzymes that degrade the extracellular matrix proteins. So, when you prevent the activation of something that degrades the extracellular matrix, you strengthen the extracellular matrix. Function 2, it helps regenerate the extracellular matrix by promoting collagen synthesis. So collagen is the main structural protein in connective tissue such as skin. So when more of it is made, the stronger that connective tissue becomes. Function 3, it inhibits keratinocyte differentiation and promotes keratinocyte proliferation. Keratinocytes are the cells that produce keratin, which is what most of your skin is made out of. So when you promote the proliferation of keratinocytes, you have more keratin and you have thicker skin, especially as you go towards the base layers. Function 4, it reduces oxidative stress by reducing the number of free radicals that are oxidizing proteins in your skin. When you oxidize a protein, you render it inactive. Oxidizing a protein means you remove an electron from that protein, which causes an imbalance in the charge and kind of wreaks havoc in your body. So when you reduce oxidative stress, you help prevent aging because you help keep the proteins in your skin functional longer. In vitro studies of retinoids in mice have established that it has this oxidative property. So aside from those 4 functions that have to do with the nuclear receptors, retinoids have other biological effects. For instance, retinoids have side chains made of conjugated double bonds. Conjugated double bonds are able to absorb UV light because the electrons in conjugated double bonds can be excited to a higher energy state, and this absorbs the energy from the UV light. Studies on animals have shown that retinoids can prevent UVB-induced apoptosis. UVB is a harmful sun ray, and apoptosis is programmed cell death. They can also reduce DNA photo damage, which is damage to DNA by solar radiation that can lead to, for example, cancer. I also want to quickly note that if you ever see retinol acetate or retinol palmitate, which are vitamin A ester derivatives, listed as skincare ingredients, remember that there's actually no research establishing their efficacy as topical anti-aging agents, or at least no research that I've encountered. So you might want to be a little bit more careful around those products because they might not work. The reason why they may be less effective is that additional energy is required to cleave that ester bond to turn it into a carboxylic acid, and that activation barrier might just be too high for it to take place ever or quickly enough to be an effective skincare ingredient. Okay, now that we have some background, let's get into the literary analysis portion. So I'm going to be talking about 3 studies discussing the efficacy of retinol as an anti-aging agent. 2 found it effective and 1 did not. Our first study was a randomized double-blind vehicle-controlled study involving 23 patients. 2 blinded dermatologists indicated that 0.4% topical retinol reduced the appearance of fine wrinkles after 4 weeks of treatment. Biopsies of all patients indicated increased expression of glycosaminoglycan, which is a component in connective tissue, and collagen production. These dermatologists advised that retinols should be used for 2 to 3 months before effects can be observed, but effects were observed. And the study seems to indicate that retinol can be used for treating aged skin. Our second study also aimed to analyze the effects of retinol treatment on facial skin appearance, specifically wrinkles. Female subjects used a 0.1% retinol formulation during a 12-week period. Proprietary software with an acronym that comes out to FACES was then used to track the extent of facial wrinkles during this time period and generate a wrinkle score to reflect both wrinkle number and wrinkle severity. Wrinkle reduction in the experimental group was observed as early as 4 weeks into this process, with a wrinkle score reduction of 58.68% at the cheeks and 27.93% in the eye areas. At the 12-week mark, wrinkle scores were reduced by 63.74% at the cheeks and 38.74% in the eye areas. Definitely non-trivial results. Furthermore, analysis of skin biopsies indicated that both retinol and retinoic acid, direct quote, increased epidermal thickening, upregulated gene expression related to skin functions, and increased collagen synthesis in skin. However, our third study showed different results. In this randomized double-blind study comparing a topical retinol, retinoic acid, and a placebo, biopsies were taken at 0, 6, 24, and 96 hours and were analyzed. They showed that the topical retinol didn't produce increase in levels of retinoic acid, which is what we predicted in the mechanism above, but it did show epidermal thickening and increased binding protein levels. Retinol caused less redness in the skin in the form of erythema than retinoic acid. So that part is consistent with the above-mentioned mechanism, but we didn't actually observe that 2-step conversion, which would substantiate the efficacy of retinol as an effective skincare ingredient. A potential reason for this might be that they only took skincare biopsies at 96 hours at the longest period, and that reaction just needed longer to be able to pick up on the retinoic acid, or that it was processed too quickly, but it did observe something. So this study doesn't completely discredit retinol as a skincare ingredient. In addition to its anti-aging effects, retinol can be used to reduce pigmentation, such as dark spots. So in a small, uncontrolled, non-randomized clinical trial of 18 patients, so we already see some weaknesses to the study design, that used 10% retinol, 5% hydroquinone, and 7% lactic acid, 2 surgeons concluded that 16 of 18 patients experienced a greater reduction in pigmentation when using retinol. So there was a decrease in pigmentation. The study does have some weaknesses because it was not randomized and there were very few patients in it. I'm less concerned about it not being controlled because it did compare retinol to hydroquinone and lactic acid, which are also fairly well-known ingredients, but having placebo or a vehicle in there would have also been helpful. But it does make sense that retinol would lead to a reduction in pigmentation if it is promoting so much skin renewal. I also wanted to briefly discuss retinaldehyde, which is that intermediate structure in the two-step conversion that we talked about. In a study where 229 healthy volunteers had 0.5%, 0.1%, and 0.05% retinaldehyde applied to one forearm and a vehicle to the other for 1 to 3 months, biopsies indicated increased presence of retinoic acid and biological activity, similar to the direct topical application of 0.1 retinoic acid. So this essentially suggests that that conversion from retinaldehyde to retinoic acid was taking place. In another study, which was a double-blind controlled trial comparing topical 0.05% retinaldehyde, 0.05% retinoic acid, and a vehicle, 125 patients applied the topical agents for 44 weeks, so long study period. They were reviewed at weeks 18 and weeks 44 in order to assess the appearance of crow's feet on their faces. Retinoic acid and retinaldehyde both showed a reduction in the appearance of crow's feet, whereas the vehicle did not. Retinaldehyde was also better tolerated than retinoic acid, which is known to cause burning, scaling, dermatitis, all the negative side effects that we've discussed as well. So these studies seem to indicate that retinaldehyde is an effective agent in combating wrinkles, whereas crow's feet were used as a proxy for wrinkles in general, and caused less irritation than the alternative of retinoic acid. In vivo studies have also shown that retinaldehydes have mild antibacterial properties if used consistently over 2 weeks. So for our final study, I wanted to compare the efficacy of a retinoid to another common exfoliating agent, in this case glycolic acid. This study looked at epidermal thickness and renewal of the stratum corneum, which is the uppermost layer of the skin, on hairless mice. It tested the active ingredient in gel, gel cream, and cream formulations of 6% glycolic acid and 0.05% retinoic acid daily for 1 week. And it determined that retinoic acid was more effective because it decreased the thickness of the stratum corneum, which is an indicator of active exfoliation. Keep in mind that we did say that retinoids lead to epidermal thickening, which means thickening of the skin, but that thickening mainly happens in the base layers of the skin as opposed to the uppermost layer. This is also a good moment to talk about the fact that retinol should be used with caution. It is an active ingredient and it has active effects on your skin. So we just talked about how it literally reduces the thickness of your skin in the uppermost layers, which makes it more vulnerable to, let's say, the sun's rays. So you always want to be using sunscreen when using retinol products, and for 1 month after use, because that's the amount of time that it takes for your skin to kind of like build itself back up. You also don't want to be layering on a lot of harsh exfoliants on top of each other. So when I use a retinol product, I only use a retinol product, along with, of course, my moisturizers and oils, etc., and then I'll switch off from using the retinol after a few months, and I'll use an AHA blend or salicylic acid or something else, and then I'll come back to the retinol, so as not to weaken my skin and not to use ingredients that are too harsh on it for too long. Anyway, that's everything that I wanted to talk about. Thank you for joining me in this discussion of retinoids. I really enjoyed doing this research and sharing it with you. If there's another skincare ingredient that you want me to make a post and a video on, please comment down below or get in touch with me some other way, and I will definitely consider it. I'm thinking of lactic acid for my next part of this series. Other than that, I hope that you enjoyed the video. If you want to support my channel, like, subscribe, do all the usual things, and I hope to see you back in my next video. Goodbye.